Suppose your kitchen wardrobe is found so messy and your mother asks you to organize the kitchen. What will you do? You will organize the kitchen wardrobe in such a way that the plates are arranged in one rack, the bowls are kept in another rack, and you keep the cups separated from one another, right? Have you noticed something particular in this? Sets of similar utensils are kept together, or you can see separate collection of utensils. A collection of plates, a collection of bowls, a collection of cups, etc. This collection of objects is simply what we call as set. Another real life example where you can relate the concept of set is a mobile showroom, where you can see a collection of smartphones and a collection of mobile phones. These collection of objects have some mathematical properties associated with it. And in this video, we are primarily dealing with those aspects of sets. Let's see the mathematical definition of set. Set is a well-defined collection of objects. The objects in the set are called as elements or members of the set. So, the highlighting term here is well-defined. What do you understand by well-defined? Well-defined means it should be unique. For better understanding, let's discuss some examples. Consider the months of the year starting with letter J. Is it a set? When you get a question to identify whether a given collection of objects is a set or not, ask yourself these questions. Is it a collection of objects? Is it well defined? Let's check these two things. We know the months of the year starting with letter J are January, June and July. So it forms a collection of months. Now, is it well defined? If I ask the same question to another student, will the answer be the same? Yes. So it is well defined. So we can say the months of the year starting with letter J is a set. Alright. Now let's look at another example. If you ask me to name 4 favorite foods, I'll say burger, ice cream, noodles, pizza. Will you have the same answer? May or may not be. Therefore, a collection of 4 favorite foods is not a set. So, we have learned to identify whether a given collection of objects is a set or not. Now, we are in a position to learn the deeper concepts of sets. Let's see one by one. The very first question is how to denote a set and its elements. Any idea? Usually, we use capital letters to denote a set. Set A, set B, set C, and so on. While the elements of the set are represented by small letters, small letter A, small letter B, small letter C, etc. If X is an element of a set P, we say X belongs to P. We use the Greek letter epsilon to denote belongs to. Mathematically, we write it as X epsilon P. On the other hand, if Y is not an element of a set P, we say Y does not belong to P. Mathematically, we write it as Y epsilon naught P. So far, we have discussed the verbal description of the set. Let's discuss the mathematical representation of a set. There are primarily 2 ways to express set. The one is roster form. The other is set builder form. Let's discuss one by one. Let's look at some examples of set. Set A is equal to 2, 4, 6, 8, 10. Set B is equal to 1, 3, 5, 7, 9. Set C is equal to A, E, I, O, U. As you can see on the screen, the elements in each set are separated by commas and they are grouped within the curly braces. Such a method of representation is called roster form, or it's also called as tabular form. Let's discuss one example. Can you see the image on the screen? What is it? A rainbow, right? Can you suggest the colors in a rainbow? Can you put down these colors in roster form? Yes, of course, we can. What are the colors? Violet, indigo, blue, green, yellow, orange and red. They are enclosed within the curly brackets. Next, we will see the rules to be noted while structuring the set in roster form. First thing to be noted is regarding the elements. Elements should not be repeated. Have you heard about this funny palindrome? No lemon, no melon. Its roster form will be N, O, L, E, M within the curly brackets. As you can see, the letters are repeated, but they are written only once in the roster form. Second thing to be noted is about the order of the elements. The order in which the elements are listed is irrelevant or insignificant. That means one can put down the elements in any order. Taking the same example, no lemon, no melon. Its roster form can be written in other ways. Set M, E, L, O, N is one way. Set N, O, L, E, M is another way. While framing a set using roster form, we face some limitations. When we express large data in roster form, we usually write the first few elements and the last element, and the commas are used to separate them. For example, set of all prime numbers between 1 and 100. You get set A is equal to 2, 3, 5, 7, 89, 97. We cannot show all of its elements in a single row. Why? Because it's a time-consuming task. Roster form is less appropriate while handling large sets of data. So, do we need another method for representing large set of data? The answer is yes. And the method is the set builder form. Set builder form can be used to represent a set by describing the properties of its elements. And the general representation is open curly bracket x colon properties of x close the curly bracket. We describe the elements of the set by using a letter x, or you can use any other letters, which is followed by a colon. Then special characteristics of the element are specified and the whole description is kept inside the curly braces. The whole description is read as set of all x such that properties of x. For better understanding, let's go through one example. Set of integers including and between 10 and 30. So, we can understand x is an integer and x is greater than or equal to 10, but x is less than or equal to 30. So, the set builder notation will be x colon x element of z, 10 less than or equal to x less than or equal to 30. Now, a natural question arises, why do we need to learn concepts of sets? Maths is all about numbers, right? Can you see a group of numbers on the screen? 1, 2, 5, 23. Can you guess which group these numbers belong to? Collectively, they belong to the set of natural numbers, which is represented by capital N. Can you guess the next set of numbers? Minus 5, minus 11, minus 47, minus 80. This is a group of negative integers. They are represented using letter Z minus. Learning sets will help to organize the numbers not only in these groups but also in other groups. For example, Q represents the set of rational numbers. R represents the set of real numbers. W represents the set of whole numbers. And P represents set of prime numbers, and so on. Thus, set theory aids in explaining collection of objects in a better and easier way. Now, do you think the benefits of learning sets are confined to this? Let's find out. Now that we have learned the fundamental aspects of set, let's have a recap.
Manorama Horizon. Learning made simple.